Alright, so we're coming back to this program here, and now that we talked about local variables and you had a chance to identify some in your challenge exercise, I want to talk about global variables. Now, a variable is global if it's created outside of a function definition. And so you can go ahead and create a variable outside of a function definition, like right here I could say maybe alligator is equal to 9, right? You could do that. You could put the variable that's being created anywhere you want outside of the function definition. Right? The program's still going to run. Right? You see it right down here, I'll put 5 to the 2 is 25. So it still runs, but what all Python programmers do, and actually all programmers in general, is that they create any global variables, meaning any variables that are being created outside of a function definition, they always put them at the top of their program. So they always put them right there before the function definitions. Okay, so the structure is the top of your program has your global variables, any that you created, and then we have our function definitions, and then at the very bottom we have main, a call to main. That's just the standard format. So if you ever want to create a global variable, you want to do it at the very top of your program. Okay, and let's see. Okay, so what we could do here is we could say base is equal to 0. We could say exponent is equal to 0, and we can make these two guys global. Okay, now what does it mean if a variable is global? Well, if a variable is global, what that means is it can be seen inside all of the function definitions. It means that it could be seen throughout your entire program. It can be seen on line 7, it can be seen on line 12, it can be seen on line 19, it can be seen on line 22 and 25. All right. Global, what we say is it has global scope. Okay, and so yeah, if we create a variable outside of the function definitions, that means it could be seen in all of the function definitions, and it could be seen in your entire program. So what you might think to yourself is, okay, well, I'm going to make base global and I'm going to make exponent global. That way, when I'm here, I'm going to be using the global base and the global exponent. Now, if I use the global base and global exponent here and here on line 18 and 19, that means I do not need to pass in base and exponent to power. Right? And that means I do not need to take in base and exponent as parameters. And that means that right down here I could use the global exponent variable and the global base variable. Okay, so you might be thinking that to yourself. And you know what? You're actually right. You could do that. Okay, and it might make life a little bit simpler for this small little program. And when I say simpler, it'll make it simpler because we don't need to worry about arguments and we don't need to worry about parameters. All right. So we're right here, and just one thing that you need to know about global variables is that if you're going to use them in a function definition, you need to say global, base, and exponent. So you need to list the global variables that you're going to be using in that function definition. Now the program knows that, hey, on line 20, I'm talking about the global base. Right? On line 21, I'm talking about the global exponent. Now if I erase that, you'll see that these guys are gray. And why are they gray? It's because it's the program, if you remember from the last video, is it's saying that, hey, you have this variable, local variable called base, local to main, but he's not being used anywhere. You have this local variable exponent to main, but he's not being used in main. So since they're not being used, they're grayed out. Okay, but if you're trying to say that I want to use the global variable base and the global variable exponent, then you have to state that here at the top of your function definition. Now what this line is saying on line 18 is, if I ever talk about base in my function definition for main, or if I ever talk about exponent in my function definition for main, I want to be talking about my global variables. Okay, so let's go ahead and do that here and do that here. And let's run the program and let's see if this actually works. So let's run it. I'll say base of 5 to the 3. I think that's 125. Yes. Right. So the program still works. Right? And some of you might be thinking to yourself, well, I like global variables. I sure do like them more than local variables, because the idea of passing in arguments to power and receiving them as parameters in the function definition for power just doesn't really make sense to me. I like the fact that I can make a variable global and he's able to be seen in all my function definitions. That makes more sense to me. And you know what? It actually does make more sense, right? The whole system of passing in arguments and receiving parameters, it's confusing for a lot of students. And I need to explain it in different ways. I need to say, okay, well, here's the quarterback throwing the football. The football is the arguments. And then here's the wide receiver, and he is catching the football as parameters. Okay. Sometimes I need to explain it as an island, where these function definitions are like islands, and you can't get from one island to another island, right? If a variable is being birthed or being created on the power island, then he cannot be seen in the main island, right? So I need to use these kinds of explanations to explain the arguments and the parameters system, because it doesn't really make sense right off the bat. But let me just tell you this. Global variables are seen as bad, okay? So global variables are looked upon as not good. So what I mean by that is that they're looked upon as not good is that if a variable can be local, then it should be local, right? If a variable must be global, that's the only reason why you would want to make it global. And you might be thinking to yourself, okay, well, what's a situation where a variable should be global? Well, a variable should be global if it's something that all your function definitions are going to use. All right. Let me give you an example. Let's say we have a video game, and the video game is huge, right? It's like maybe 5,000 lines of code, which is not very big at all, right? The games that you play on Xbox and PlayStation, even on a handheld system like Nintendo's handheld system, they're gigantic. Okay, they're far bigger than 5,000 lines of code. Now, if you had a variable that needed to be seen in all the function definitions for these gigantic programs, then that's a very good reason to make it global. So what would be a example global variable? It might be sky color, right? And you're going to set it equal to blue, right? That's something that everybody needs to see, and that's something that makes sense to be a global variable, right? Or maybe I could say world dimensions, right? And let's maybe make it 1 million pixels wide, right? So let me world dimensions. I could say the x dimension, and I could say world underscore dimension underscore y dimension is equal to, I don't know, maybe little smaller number, right? So yeah, so these are examples where it's like, okay, this makes sense to make these variables global because they're going to be need to be seen in all of the code that I've created that for my video game. Okay. Now for these small little programs that we make here, there's really not a good reason to make our variables global. Okay. Every once in a while, yeah, we'll make a variable global. Okay. But this base and exponent, we could make it local. So we should make it local. All right, so we should not be doing this global. Let's go ahead and delete all of this stuff. Let's replace the parameters here to B and E. Let's come down here. Let's do that. Let's set up our base and exponent back as arguments. and we are ready to go. So now this program is more palatable, meaning programmers that are experienced will look at it and say, okay, this makes sense. This follows the rules of if a variable could be local, it should be local. And if a variable is global, then there's a really good reason to make him global. All right? And so none of these variables here have a really good reason to make them global, so they should not be global. And let me explain to you a little bit more about why this is the case. All right, let's go back to the example of a video game developer. Right? Normally, video game developers have teams of about 50 to 100 people. And why is that? It's because there's so much work involved in creating a video game. But let's go ahead and shrink that down a little bit, make it a little bit more simple. Let's say we have this video game developing team that is 5 people, right? That have 5 people. And you are the senior software developer, meaning you are the one who's designed the entire game, and you are going to assign programming roles for each of the 5 people on your team. So you're going to say, okay, person number 1, you program the introduction, right? The intro screen where you need to select start and select your options to start the game. Okay, person number 2, you go ahead and create the portion where the player customizes their character and chooses which character they want. Okay, programmer number 3, you program the first task or the first job that the player is going to take part in when they first start the game. Maybe it's like the tutorial portion, and so on, right? So you're going to assign each person a different part of the game to build. Now, if you do that, and if all the programmers have the mindset of, oh, okay, well, you know what? I like global variables. They make more sense to me than local variables do. I'm not going to do this parameter argument system. I'm just going to make all my global variables global, and that way I don't need to worry about that. Okay, so all of the 5 programmers go ahead and start building their portion of the game. They have different functions, right? They have different global variables that they create up at the top. And when they do that, a lot of them are going to be making the same variables. They're going to make an X variable, a Y variable. They might make a name variable, right, is equal to Daniel. They're going to make these global variables at the top of their program, and they're going to be using descriptive names, right? Because that's what variable names should be. They should be descriptive. If it's going to contain the character's X position, you call it X. If it's going to contain the character's Y position, you call it Y. If it's going to contain the character's name, then you call it name, right? It makes sense. So they all go and program their portions of the game. Then when they're finished, they come back to you and they say, okay, well, here's my portion of the game. The other person comes and says, here's my portion of the game. And the other person comes and says, here's my portion of the game. Well, you as a senior software developer, when you put this all together again, what you're going to find is that a lot of those programmers use the same names for those global variables, all right? And because they use the same name for the global variables, it's going to mess everything up. Because what if I had another X here and I said it's equal to 10 and another Y here that's equal to 14? Let's say this is coming from the first programmer and this is coming from the second programmer. And not only that, but let's say we have another X is equal to 9 and a Y is equal to 5, right? This is coming from the third programmer. Well, now whenever X is being talked about over here, right? X is equal to like X plus 8. Well, now the program doesn't know like which one does it want to use. Does it want to use programmer 1's X, programmer 2's X, or programmer 3's X, right? And actually what it's going to do is it's going to use the last variable, because when we create a variable X here equals 0, and then we create a variable X here equals 10, the first X is gone. Right? X is now equal to 10. And then when we say X is equal to 9 on line 12, well, the X is equal to 10 is gone. Now X is equal to 9. All right? So if everybody uses global variables, then when you go ahead and compile the program together and put it all together, it's going to cause problems, because many of the variables are going to have the same names, meaning many of the variables are going to be overwritten. right? This one's going to be overwritten, this one's going to be overwritten, and this one is going to be what x is going to be equal to. So that's the reason why we try as programmers to keep everything local. So now if person one created an x variable here and kept it local to power, and then player two created an x variable and kept it local to main, and then you go ahead and compile all the programs together, all the function definitions together, then you won't have any problems, because this x is different from this x. This x exists in this power function definition. This x exists in this main function definition, and they don't overwrite each other. Okay, and so that's the power of locality of variables. They allow you to be able to work in teams without having problems like I just described. So again, the main rule is if a variable can be local, it should be local. And if a variable is global, there better be a very good reason why the variable is global.